Hello everyone. As we started the introduction part, the topics what we are going to cover, right? Let us start the first chapter, chapter 1. Fundamentals. When I say fundamentals, there are many fundamentals, but whatever required for analog circuits, I am going to explain those things. Just don't write until unless I say, okay? Just listen. Number 1, ideal voltage source. See, I am going to explain. Let me give you like a little bit prerequisite background what I want to explain. I am going to explain what is ideal voltage source and ideal current source, ideal resistor, and I am going to extrapolate the observations or summary from these three topics to like a capacitor, inductor, PN junction diode, BJT, JFET, MOSFET, etc. any device. But I cannot explain all the devices at the same time and then do something. Therefore, I want to explain kind of observations and then summary based on already we are very much familiar with voltage source, current source and the resistor, inductor, capacitor. Therefore, let me start with ideal voltage source, and I am not going to explain what is ideal voltage source and all. I am going to explain what I need which is important to analog circuits. Okay. Now, ideal voltage source, because we have studied already what is ideal voltage source, ideal current source, resistor, inductor, capacitor from network analysis. But the way I am going to see the voltage source and then the way we are going to have the observations, that is what is very important. Okay. Now, if you take ideal voltage source, what is ideal voltage source? The voltage source which is ideal, right? Yes. What does it mean? What does it mean? If you take a battery, let me take 10 volts battery. Therefore, when can you say this is ideal? Whatever may be the current which you draw from your voltage source, it has to maintain the voltage which is what is 10 volts. Let us say this is what is my black box. When I say this is what is my black box in the sense I don't know what is there inside, then I want to characterize this. Remember, in electronics or in the electrical domain, if you deal with the power, electrical power, which is combination of voltage and current, we need to get the characteristics of the device. Let us say voltage and current characteristics. If you take PN junction diode, VI characteristics of PN junction diode. If you take BJT, VI characteristics of your BJT. But we say input characteristics and output characteristics. MOSFET, input characteristics, output characteristics. But always we try to characterize with respect to voltage and current. Therefore, similarly, I want to characterize your voltage source with respect to voltage and current. What is voltage? The voltage what we are trying to get from your voltage source. And what is current? The current what you are trying to draw from your current source. Voltage source. Therefore, I want to characterize with respect to voltage and current of your ideal voltage source. For that, if I take a battery something like this, I will not get any current. Therefore, to get current from this voltage source, right, then let me connect a load. Remember, I am connecting this load to characterize my voltage source with respect to voltage of voltage source and current what you are drawing from your current voltage source. Therefore, for your understanding, let me take the load RL is equal to 1 ohm. If I took load RL is equal to 1 ohm, then tell me using your network analysis, what is the current which is what is flowing through it? The current what you are, or what the voltage source is passing through the load is nothing but 10 divided by 1 ohm. It is nothing but 10 ampere. Okay. Now, I want to characterize, I don't want to characterize the load, I want to characterize my voltage source. If I want to characterize my voltage source, what I want to say is, let us say, what is x-axis and then what is y-axis. See, what is dependent and what is independent. Here, strictly speaking, in this circuit, I can say that my load is independent. Load can be anything. When I say load can be anything, what does it mean? Let us say the bulb is connected to your battery. When bulb is connected to battery, you can connect 1 ohm bulb or 10 ohm bulb or 100 ohm bulb, that is independent. Therefore, here load is independent. When I say load is independent, then tell me which one is changing. I can say current is changing. Assume that this is what your ideal voltage source, giving always 10 volt battery, if that is what your expectation, right? And that is what your ideal voltage source. Whatever may be the current which you are drawing from your voltage source, the voltage from your voltage source should be constant, right? Then when I say RL is equal to 1 ohm, I am getting current 10 ampere. When RL is equal to 10 ohm, let us say it is 10 ohm, then what is the current? Then the current is 10 divided by 10, therefore it will become 1 ampere. And let us say my RL is equal to 100 ohm, then what is your current? That is nothing but 10 divided by 100, you will be getting 0.1 ampere. I can stop with this and then we can analyze. What is the meaning of it? If the load is changing but load is independent, load can be anything. When load is changing which is not in your hand, let us say, then the current whatever you are drawing from your voltage source is also changing. Therefore, what is independent? Load is independent. Therefore, current is independent. Always we represent independent parameters in x-axis. Then what is dependent parameter which you are observing? What are you observing? I am observing the voltage from your voltage source. And what are you expecting from your ideal voltage source? I am expecting constant 10 volts from your ideal voltage source, irrespective of the current or irrespective of the load what you are connecting to the voltage source. Therefore, the load variation is translated into current variation because I want to characterize my voltage source or black box with respect to voltage and current or current and voltage. Therefore, as I told you, all electronic components we are trying to characterize with respect to voltage and current. Similarly, I am trying to characterize the battery or ideal voltage source with respect to voltage and current. Therefore, which is x-axis, which is y-axis. I can say that because load can be anything which is translated into current variation. Current can be anything. The current whatever you are trying to draw from your voltage source can be anything. But I am expecting the constant output voltage from the battery, then only that is what is called ideal voltage source. Therefore, whatever sentence format we are giving it to ideal voltage source, saying that whatever may be the current you try to draw from your voltage source, I am expecting constant output voltage from the voltage source. Therefore, now I got the relation between voltage and current from your ideal voltage source. Therefore, indirectly we are trying to translate to the graph which is nothing but VI characteristics of voltage source. Then x-axis is current which is nothing but independent parameter. This is your independent parameter. Independent parameter. And y-axis is a dependent parameter, right? Then let me say this is what is voltage V. Therefore, I am just explaining once again. I is nothing but independent parameter because load can be anything, current can be anything. And here the dependent parameter is nothing but voltage. Therefore, this is depending on current, but I am expecting the voltage should not change with respect to current. But if you take practical voltage source and all, the voltage what you get from your voltage source is depending on current. That's why this is dependent parameter. But if you say ideally, I am expecting the voltage to be constant. This is what I am expecting. Therefore, I am expecting 10 volts irrespective of the current what you are trying to draw from your voltage source. Fine. Now, this is what is explained with respect to VI characteristics. Therefore, if you ask me VI characteristics of your black box interested element which is nothing but your ideal voltage source, we got the characteristics. Therefore, what is it saying? If current is changing, whatever may be the current, the voltage what I am expecting from your voltage source is equal to 10 volts. This is known to everyone, but what I want to observe here is very important. Now, every time explaining with respect to graph is difficult. I want a technical term which is what is correlating the relation between voltage and current. The technical term are the relation or the ratio between voltage and current is nothing but resistance. Therefore, I want to speak in terms of resistance of your voltage source. Then when I speak about resistance of your voltage source, and if you know the relation between voltage and current, right? Instead of explaining through graph, I can explain indirectly with the resistance parameter. That's why the resistance has come into picture for your voltage source. Now, let's see what is resistance of your voltage source, right? Now, there are, when I speak about resistance, resistance of your voltage source, or resistance of your current source, resistance of your resistor, resistance of your inductor, resistance of your capacitor, resistance of your PN junction diode, resistance of your BJT, resistance of your JFET, resistance of your MOSFET, resistance of your UJT, etc. You take any element. Remember, whenever you want to characterize with respect to voltage and current, instead of speaking with respect to voltage and current, which is through graphical format, we can speak with respect to the resistance parameter, which is nothing but ratio of voltage and current. You understand? Therefore, when I speak about resistance, it's not the resistor only. Resistance is nothing but which is what is giving the relation between voltage and current of any element. That is what I want to say. But even though I'm saying resistance, there are two definitions associated to resistance. Number one, static resistance. Number one, static resistance. Number two, dynamic resistance. Now, let us calculate what is static resistance of your voltage source, and let us calculate what is dynamic resistance of your voltage source. Okay, and which one is applied and which one is valid, and why only one of the two resistances is valid or both are valid. Let us see. Now, from the definition of static resistance, what is that? The definition is nothing but the resistance of your voltage source. Resistance of your voltage source is equal to, remember I am speaking resistance of your voltage source because this is what is my interested element, or this is what people say DUT, device under test. This is what we are trying to characterize or test with respect to V and I characteristics. Now, resistance of voltage source is nothing but voltage from your voltage source divided by current which you are drawing from your voltage source. If I say, then this is what your static resistance. Then what is dynamic resistance? See, all static parameters we represent with capital V, capital I and the capital letter R. That is what your static parameter. Static parameters are DC parameters we represent with capital letter, and system gain parameters, that is a voltage gain, current gain, trans conductance gain, trans resistance gain, input impedance, output impedance. Those things also normally we represent with capital letters, even though that is what is related to some AC parameter. But normally for DC signals we represent capital letters, and systems gain also we represent with capital letters like H of S, G of S, etc. Now, dynamic resistance. When I say dynamic resistance, it is associated to dynamic parameters or AC parameters. Let us say the change in the voltage, the change in the current, we are applying with AC voltage source and AC current source. Let us say, then the definition is R, small r, dynamic resistance. This is what is R of your voltage source. Similarly, small r of your voltage source. This is what is small r is indicating dynamic, which is what is change. Then we represent like what is the change in the voltage due to the change in the current. This is what is the definition. When I speak about static resistance, static voltage to static current, and when I speak about dynamic resistance, dynamic voltage to dynamic current. This is what is the definition. Now let us use these two definitions for your ideal voltage source, and then let's see what are we getting, right? Let us say case A. Tell me, when current is equal to 10 ampere, when current is equal to 10 ampere, when current is equal to 10 ampere, don't write. I'll give you time to write down all these things. First of all, listen what I'm saying here. This is important point. The observations are very important, which we are going to see, and I'm going to extrapolate those observations to all our semiconductor devices. Okay. Now, when I is equal to 10 ampere, what is that? The current what you are drawing from your voltage source is 10 ampere. Then tell me what is your static resistance? R is equal to, I'm not writing voltage source subscript. R is nothing but your static resistance of your voltage source is nothing but V divided by I. Therefore, tell me what is V? The voltage what we are getting from your voltage source is 10 volts. I can explain the same thing from your, let us say, when I is equal to 10 ampere, some current, what is the voltage? 10 volts. Therefore, this is 10 volts divided by, what is the current? 10 amperes. Then what is the resistance? This is what is giving 10 ohm. Therefore, if you take the definition of V by I, static V by static I, the voltage what we are getting from your voltage source and the current what you are drawing from your voltage source, then that is what is 10 ohm. Let's see for other current. Therefore, I is equal to, let us say, 1 ampere. Then what is your R? R is equal to V by I. That is the definition. Is equal to, what is V? Even though the current what you are drawing is 1 ampere, I am expecting 10 volts. Therefore, this is what is 10 volts divided by, what is the current? The current is nothing but 1 ampere. Then what are we getting here? Therefore, sorry, this is nothing but 1 ohm and this is 10 ohm. Now, KC, then current is equal to 0.1 ampere. Actually, 3 points are enough. Using 3 points we can extrapolate. Okay. Now, what is R? R is equal to V by I. What is V? 10 volts. And what is I? 0.1 ampere. Then what is this 10 by 0.1? It will be 100 ohm. Therefore, what is it? When you take the definition of the voltage source resistance, the static resistance, which is V by I, strictly speaking, R is equal to 1 ohm, 10 ohm, 100 ohm, that is nothing but your load. Therefore, if you take the static definition of your voltage source, like the voltage from your voltage source and the current what you are drawing from your voltage source, that is what is not giving the resistance of your battery, that is what is giving the resistance of your load. Because the voltage, whatever voltage you are getting from your voltage source, that is what you are applying to the load. Whatever current you are drawing from your voltage source, that is what you are trying to pass through the load. Therefore, indirectly V by I across the resistor, therefore that is nothing but resistance value. But our interested element is voltage source, and I am trying to characterize with respect to the voltage and current. What is the current which you are drawing from your voltage source and what is the voltage which you are getting from your voltage source, and this is what is flat, which I am expecting, then only that is what is called ideal voltage source. This is what I am expecting, but if this is what I am expecting, what is the resistance? If I calculate of your voltage source, then if you take static resistance, which is what is giving the load value but not the resistance value, means which is not representing the resistance value of your voltage source. Now, coming back to the dynamic definition. What is dynamic definition? What is the change in the voltage because of the change in the current? Therefore, what is the change in the voltage because of change in current? Therefore, let us say there is a change in the current. Therefore, there is a change in the current. Yes. Let us say this is what is 10 ampere, this is 1 ampere. Then what is the change in current? There is a change in the current which is not 0. Let me take it as a finite value. Right? But what is the change in the voltage? Therefore, if you ask me the change in the voltage delta V, that is what is 0. Remember, this is what we need. I don't want to see any change in voltage even though current is changing from minimum to maximum. Therefore, even though current is changing, I don't want to see any change in the voltage. That is what is my requirement. Then this is what is saying that what is delta V? 0. And what is delta I? Finite value. Means whatever may be the change in the current, but the change in the voltage is 0. Therefore, this is what is saying that the dynamic resistance small r is equal to 0 ohm. The meaning of this is nothing but, see, the meaning of resistance, dynamic resistance is equal to 0 means short circuit. But don't think that this is short circuit. The meaning of dynamic resistance is nothing but, even though current is changing from your voltage source, the voltage is not changing. The meaning of dynamic resistance is, even though you are drawing the current, whatever you are drawing from your voltage source, that is changing. The voltage what you are trying to get from your voltage source is not changing. Therefore, tell me which one suits or explaining the nature of your voltage source. I can speak or I can say dynamic resistance but that is not explaining what is the voltage value from your voltage source. That is only explaining what is the change in the voltage from your voltage source if the current is changing through your current source. Therefore, dynamic resistance gives the nature of ideal voltage source or the output voltage from your voltage source than if there is a change in the current. You understand? Now, just write down, then I'll give you or I'll dictate some points which are nothing but observations. Okay? Write down. See, I am going very slowly because these are all fundamentals, and let me tell you a point, all these things are known to you. It's not that you don't know, but the way we are going to observe, that is what is very important. Okay? Write down quickly. Is this done? Okay. Now, write down observations. What did we observe? From this, I can say an experiment, and this is what is our DUT, device under test. We are trying to characterize with respect to voltage and current, right? Now, just write down observations. Tell me, is your voltage source, ideal voltage source, linear or non-linear? I am speaking with respect to voltage and current. Is it linear or non-linear? What do you mean by linear? Linear is nothing but, let us say, if current is increasing, if voltage is also increasing proportional to the current, then only we can call it as linearity is achieved between voltage and current, right? Let me tell you, if I speak about linearity of your electronic component or electrical component, right, or where we deal with voltage and current, remember we speak about linearity with respect to voltage and current, default, until unless it is specified. Therefore, I am speaking with respect to voltage and current because we are characterizing with respect to voltage and current. Then tell me, is it linear? Is it what is? Is the voltage changing proportionally with respect to current? No. And I don't want that basically. I want my output voltage to be constant irrespective of the current. That is what is your voltage source. My voltage source voltage should not change. Is it linear? No, it is not linear. Write down. Write down two observations. Number one, for observations, these observations are very important to get conclusion. But first of all, let's have the observations from ideal voltage source, observations from ideal current source, observations from ideal resistor. Then after having all these three observations, then I'll give you conclusion. Okay? Observations are required for conclusion. Now, the first observation, write down ideal voltage source is a non-linear element. Ideal voltage source is a non-linear element. Ideal voltage source is a non-linear element. Over. Second observation. Remember, you can have your own observations, but I'm just taking two important observations which I need to explain something which is conclusion. Second observation, can I say the dynamic resistance is not equal to static resistance? Because our static resistance, we are getting different values, and basically this is not the resistance of your voltage source, that is resistance of the load. And if you take dynamic resistance, we got 0 ohm, right? Therefore, what is the observation? Write down. Second observation, dynamic resistance, maybe if I say, just you already, right, your voltage source, ideal voltage source is not linear, or I can say it is non-linear, And the second observation, dynamic resistance or incremental resistance, or why it is called incremental resistance? For incremental change in current, what is incremental change in voltage? That's why this is what is called incremental resistance. Or AC resistance. What is AC? Alternating current due to alternating voltage. Normally the signal which is what is changing with respect to time, that we can take it as AC signal, right? Even though it is related to current, but the current is due to the change in voltage, let us say. Therefore the signal which is changing with respect to time, you can call it as AC signal, AC voltage or AC current, whatever it may be. Now that is the terminology people follow, even though the abbreviation of AC is alternating current, but AC is nothing but the change in the signal. That is what I can say. Therefore, because of the change in the current, what is the change in the voltage? You can call it as AC resistance or internal resistance. Because why it is called internal resistance? Actually your voltage source is not a resistor. It is a battery, but internal to it we are equivalently represented with a resistance. It's not a resistor. That's why this is internal parameter. Internal resistance or equivalent resistance. When I say equivalent, what do you mean by equivalent? Equivalently, how are we representing with a resistance? Therefore, equivalently we are representing with a resistance, saying that 0. What does it mean equivalently? When you speak with respect to resistance, saying that there is no change in voltage even though there is change in current. Therefore, equivalently we are representing it. Okay. Therefore, equivalent resistance is not equal to, maybe only for ideal voltage source, I give like dynamic resistance, incremental resistance, AC resistance, internal resistance, equivalent resistance, but next time I speak only dynamic resistance. But remember it has many names: dynamic resistance, internal resistance, AC resistance, equivalent resistance, incremental resistance, etc. Is not equal to what? Static resistance. Is not equal to static resistance, or you can call this as DC resistance. Because why it is called DC resistance? DC voltage to DC current. Static voltage to static current. Therefore both are same. Therefore either static resistance or DC resistance. Therefore tell me, are you seeing both are same? No. Actually your static resistance is different with respect to different currents, what you are drawing. But if you take dynamic resistance, that dynamic resistance is 0 for any change in current. Maybe you can take the change in current here, or change in current here, change in current here. For any change in current, the change in the voltage is equal to 0. Therefore, that is what? What is the second observation? The dynamic resistance is not equal to the static resistance. Therefore these two observations are enough to continue further. Okay? Is this over? Done. Now let's see the second one. The second one is nothing but ideal current source. Okay? Let me rub. Second one, ideal current source. I'm going to use this because we need to define. Okay, I'm not rubbing it. Now I can go a little faster because we understood the motto. What are we trying to calculate, and what are we trying to compare, and what are we trying to have the observations. Okay, now second one, ideal current source. Okay, what is ideal current source? Now my current source is nothing but DUT, device under test. Let me take an example which is 10 ampere. Therefore can I say this is what is my device under test? I want to characterize ideal current source. You know, because every time we deal with voltage source and current source, therefore you know what is current source. In that, whatever we understood with respect to voltage source and current source, similarly we should understand what is PN junction diode, BJT, JFET, MOSFET. Therefore those are all 3 terminal devices if you take except PN junction diode. Therefore it is not straightforward to understand. Therefore to understand them in equivalent to our voltage source, current source and resistor are 2 terminal devices, I'm just taking all these things as like the supporting elements to exploit the concepts or observations what we are getting from here to all semiconductor devices, whether 2 terminal or 3 terminal devices. Okay, you will understand. Just give me some time, therefore you will understand. Now this is what is my characterization element. Now I want to know the relation between again voltage and current. Ultimately I want to characterize any element with respect to voltage and current only, right? Now that definitely there should be a loop. If there is no loop, we cannot see this current flowing through or coming out of your current source. Therefore to have the loop, let me connect a load. Therefore let me say this is what your RL. Again let me take an example, 1 ohm. Remember, in any case load is independent. Load is not in our hand. Okay, as a designer, if you are designing any sub block, right, if you are connecting a load here, let us say it is some system, this is what your load. Remember, load can be anything. Load is not in our hand. Okay, but it will have some variation, some range. Only for some range of loads it will perform whatever you are expecting, but the load can be anything. If load can be anything, as a designer you should design the system such that even though there is a change in the load, your gain parameters or the required parameters should not change. Here the required parameter is nothing but your current. Okay, now load is a variable here. Load can be anything. If load can be anything, right, that is what is my independent parameter. Then tell me, the current whatever you are trying to pump from your current source, that is 10 ampere, and that should be 10 ampere always, then only you will call it as ideal current source. But now already you know the current what you are getting from your current source. Now I want to translate the load change into what? Voltage, right? Therefore, tell me what is the voltage across your current source. Now I am not speaking voltage across the load, I am speaking voltage across the current source, because I am characterizing the current source, because I know the current what you are getting from your current source, and I want to know the voltage across current source. If load is 1 ohm, therefore tell me what is the voltage. The 10 ampere is flowing through the load of 1 ohm, then 10 into 1, you will get a 10 volts. This is what is our voltage. Right? Therefore indirectly we got to know what is voltage across current source, 10 volts. What is current from your current source, 10 ampere. Right? Now if your load is changing, let us say this is what is becoming 10 ohm. Then tell me what is the voltage. But the current what you are trying to get from your current source, ideal current source, is 10 ampere. That is what I am expecting. Remember, the meaning of ideal current source is translated into voltage and current through graph. That is what we are trying to do. Okay. Therefore, you are translating. The 10 ampere is flowing through the load. 10 into 10, 100 volt. Right? Again, when RL is equal to 100 ohm, I told you 3 points are enough to extrapolate. Okay. Now 10 ampere, 10 into 10, therefore we are getting 1000 volt. Indirectly, the load change which is independent is translated into voltage change. The same voltage is applied to your current source. Therefore, we understood the voltage across current source and the current what you are getting from your current source. If that is what is the scenario, now I want to characterize with respect to voltage and current. Now what is x-axis? In the case of ideal voltage source, the x-axis was current, because the load change was translated into current change. But here the load change which is independent is translated into voltage. Therefore what is independent here? But I don't want to draw with respect to load RL and I want to have V to I. Therefore I to V or V to I which is independent, that is what we need to take as x-axis. Therefore the load change is nothing but voltage change. Therefore now this is what is your independent parameter here. This is what your independent parameter. The voltage across current source can be anything. Therefore this is what is independent parameter. And the current what you are trying to expect, or what are you expecting from your current source, should be what? Constant. Then only you call it as ideal current source. It has to pump constant current through to the load irrespective of the voltage what you have across the current source. Therefore can I say this is what your 10 ampere? This is what we are expecting, right? Therefore let me say this is what is 10 ampere. Okay. What are maybe the load, what are maybe the voltage across the current source. Therefore indirectly we got the graph of your ideal current source with respect to voltage and current. Okay. Done. Now again, the meaning of ideal current source is translated into VI characteristics. Now every time I cannot, or it is difficult to represent with the graph, I want a technical term which is nothing but resistance, because the ratio of voltage to current is nothing but resistance. Therefore let's define the relation between voltage to current, which is nothing but ratio, which is nothing but a resistance. Then I told already resistance is nothing but either static resistance or dynamic resistance. Let's calculate both of them and then let's have the same or similar observations whatever we had from voltage source, right? Okay. Now tell me, case A. What is voltage? Let me take voltage is equal to 10 volts. When voltage is equal to 10 volts, tell me what is your R? Your R is equal, don't write, okay? I'll give you time, okay? What is R? R, definition is nothing but V by, remember now this is not voltage source, this is nothing but current source. We are trying to get the resistance for your current source. Similarly, current source. Okay. Now, what is that R? I am not writing the subscript, right? Let me take R is equal to static resistance is equal to V divided by I. Tell me, what is voltage across your current source? That is 10 volts. And what is current from your current source? that is 10 ampere. Then tell me, what is the resistance of your current source? That is nothing but 1 ohm. Because V by I, voltage across current source and current from your current source. Now, case B, and voltage is 100 volt. What is R? The definition is V by I. Therefore, what is V? 100 volts. And what is I? The current what you are drawing from your current source. That is 10 ampere. Therefore, what is this value? This is 10 ohm. Right? The third one, because we took 3 points. What is V? V is equal to 1000 volts. Then what is your static resistance? R is equal to V by I. Therefore, what is V? 1000 volts. And what is I? The current what you are getting from your current source. That is always 10 ampere. Then only it is ideal current source. What is this value? This is nothing but 100 ohm. We are getting different static resistances for different loads. Basically, that is nothing but your load value. We are trying to calculate the resistance of your current source, but it is giving the load value. Yes, because voltage across load, current through the load, yes, that will give you to, if you take Ohm's law, yes, we will get load value. But our characterization element is nothing but your current source. That is what is my black box. Then I am trying to characterize like this, right? Therefore, I want to know the resistance of your current source, right? Let's see, what is dynamic resistance of your current source? Therefore, tell me what is dynamic resistance? I want to know what is change in voltage because of change in current. Tell me, even though you take mathematically we are saying that delta y by delta x or delta v by delta I. Always the numerator is nothing but dependent parameter and the denominator is nothing but independent parameter, right? Therefore, are we expecting the change in voltage because of change in current? That is true for your voltage source. But here, I'm expecting what is the change in the current because of the change in the voltage. Mathematically that is the definition, but qualitatively that is not true. Right? To make it valid for qualitative analysis also, let me make it delta I by delta V. What is the meaning of it? Mathematically both are same, right? This delta V go to numerator, then delta V by delta I. But qualitatively the meaning of this is nothing but reciprocal of what is the change in the current because of the change in the voltage. Always remember, delta y by delta x means delta x is always independent. This is always independent. This is always dependent. Therefore, what is change in y? Because it is depending on x, right? What is change in y? Because of change in x. Similarly, if you say what is change in v? Because of change in current I. It is true with respect to voltage source, because what is change in voltage from your voltage source, if there is a change in the current or if there is a change in the current what you are drawing from your voltage source. That's why that time I just kept like that. But now I am not interested for change in voltage with respect to change in current. What I want, what is change in current? Because my voltage is independent. If voltage is independent, therefore now this is what is our independent parameter. That's why to make them quantitatively same, but this is qualitative explanation or qualitative definition of your current source dynamic resistance. Okay, if I take that 1 divided by, tell me what is change in current? The change in current, there is no change in current and we don't want change in current. Then only I call this as ideal current source, right? Therefore, if I take change in voltage, there is a change in voltage, let us say delta V is equal to finite value. But tell me what is change in current? There is no change in current. I am not expecting 10 ampere only, 10 ampere only. The current should not change. Therefore, change in current I2 minus I1 is equal to 0. There is no change in current. 0 ampere. That doesn't mean that current is 0. The meaning of delta I is nothing but there is a current. It can be 1 ampere, 10 ampere, 100 ampere. But that is constant. The meaning of delta I is equal to 0 means whatever current you have from your current source, that is constant. It is not changing even though voltage across the current source is changing. Okay. Having said that, what is change in current? change in current is 0 divided by what is change in voltage? Finite value. The change in voltage is finite value. Therefore, if you take this, what is this value? 1 by 0 by finite, 0. Therefore, what is the meaning of this? This is what is infinity. The resistance of your ideal current source is infinity if you take the dynamic resistance definition. The meaning of resistance infinity, if you say that resistor infinity means open circuit, right? Right? If you take normal resistor, resistance is infinity means open circuit. But here it is not simply resistor, it is resistance, internal resistance, equivalent resistance, dynamic resistance, AC resistance, incremental resistance of your current source is infinity. The meaning of dynamic resistance infinity means it is opposing. When I say resistance infinity, what does it mean? It is opposing the current. But here the meaning of dynamic resistance infinity means it is opposing the change in current. That's why it is infinity. Therefore, it is highly opposing the change in current. What does it mean? Your current will not change. Right? Therefore, current is not changing. What does it mean? Your current is constant. That doesn't mean that it is open circuit. There is a current which is 10 ampere, but the 10 ampere is not changing with respect to voltage across it. Therefore, the meaning of dynamic resistance is the change in the quantity is opposed, means there is no change in the quantity. Therefore, there is no change in the quantity, there is no change in the current, even though there is a change in the voltage. That is the meaning of dynamic resistance. But don't think that it is a resistor value, infinity means open circuit. No, it is not open circuit, right? This is representing the change in quantities. Then absolute quantity is not represented by your dynamic resistance, right? Absolute quantity, that is 10 ampere, but what is the change in the 10 ampere with respect to the change in the voltage? That is what it is explaining, right? At least it is giving some information. But if you take static resistance, that is not explaining, it is simply giving the load value. Okay? Yeah, we'll stop. Let me stop here. Then let's continue in the next session. Okay?